Alright. Ready?
Yes.
Alright, let's do this.
The gas is in the head, baby.
Let's talk about Gay-Lussac's law. Now, if you remember, oils was P1V1 equals P2V2. Charles, which I spelled again, was V1 over T1 equals V2 over T2. Alright. Gay-Lussac.
It's right down.
Any guesses what Gay-Lussac's is, or memory of his, what it is?
Isn't it like V1?
Close. We've had two of these so far, right? This is constant temperature, this is constant pressure,
P.
this is gonna be constant temperature, right? So, it's gonna be P,
P1.
and then, yep, T1, P2, T2. Do not forget, temperatures have to be in what degrees? It has to be in Kelvin, which is Celsius plus 73. We're not doing Fahrenheit, that's good news. Converting between Celsius and Fahrenheit is its own little exercise. And
Isn't it like times 1.5?
2/3
Something
plus
like that.
14 or something. I'd have to look it up, it's been a
Yeah.
long time. I don't have that one. Didn't enough time to think I'd remember it, but this is, I just prefer measuring things in Celsius, and I can skip all that because it's really easy to get to Kelvin. So this equals, and we always labeled it Kelvin, K, capital K.
Can I say something to them really quick? I hate to disturb you.
Yes, sir.
Anybody going on Appalachia Outreach in this class?
Emmanuel. You want to go to Jacob? Okay.
Okay, sorry to interrupt.
No, it's all good.
Yeah, it's all boys, no girls, okay.
That's the girls are not welcome, they are.
The girls are
Oh,
all.
wait, no, I got it wrong. I thought it was the one where we go like to, no.
No, it's not the, it's not the.
Wait,
West
Mr.
Coast.
Stevenson, can I get one?
Yeah, of course.
Don't give him one, please.
Smells good, first for you, Jacob. Okay, you guys set? So Kelvin is gonna be temperature's gonna be Kelvin. Pressure 1, temperature 1, pressure 2, temperature 2. We're going to do the same thing as we did yesterday with these problems. We're gonna read it and we're gonna label it. Ready? There's a whole bunch on this one. There's only 2 problems. Yeah, so there's not actually a whole lot. Gases in a hairspray can are at the temperature of 27 degrees Celsius and a pressure of 30 pounds per inch squared. Inch squared is area, by the way. If the gases in the can reach a pressure of 90 pounds or inches squared, the can will explode. This is what happens when you put it into a fire. To what temperature must the gases be raised in order to make the can explode? Assume constant volume. That's finding out. Alright, please tell me what 27 degrees C is. Correct. Which means I have to add what to it? 273. How do you know? because it's the first one listed.
Damn, you're so dumb.
I thought they had new minutes, everything else. But P1 is 30 pounds,
Correct?
and then T2 is missing.
30 pounds per inch squared.
Yeah.
And you said what was missing, T2?
T2,
Yep, T2, question
and
mark.
then P2 is 90 pounds, and then the inch thing.
Correct. Inch squared,
Yeah.
pounds per inch squared. Okay,
And then we plug it into the equation, right?
right, we're gonna take our formula. I'm gonna solve this one for T2. I'm gonna do it a little differently than I did yesterday. P1 over T1 equals P2 over T2. I'm just gonna flip everybody. Does that make sense? So I'm gonna take the inverse of both sides. So I have T1 over P1 equals T2 over P2. I'm trying to take a shortcut.
How come we do this today?
We're doing this today?
No, like, how come like you did that? You didn't do this yesterday. Like you didn't do it.
I know, I didn't do it yesterday.
Necessary, or you just doing it?
No, I'm taking a shortcut.
Alright.
Cause otherwise I've gotta multiply both sides by T2. Then I have to divide both sides by P1, and then I have to multiply both sides by T1.
Alright, so now what do we do?
Now I just multiply both sides by
You
P2
wait.
and I'm done. No, he's good. So T2 equals T1, P1 times P2, and I'm done.
That's
See?
the answer?
No, we just
No,
solve
that's
it.
the formula.
What?
Now you just use the plug.
Now I can plug my numbers.
Why is like all my space up on my paper?
Right, smaller.
I was like the smallest I can write.
We should say how a contest and see who can write the tiniest. You can do these miniature books. That'd be fun. Alright, so T2, what's T1?
300.
300.
Cause you did the 273 plus the 27, how much?
Yeah, 300 and what?
It's just 300, 27 plus
Oh.
273 is 300.
You're right, sorry.
Oh,
You sound a little
yeah.
testy and a little unhappy about that whole process. Alright, so 300? I'm glad you think it's easy. P2 is 90.
And then it's gonna be over 30.
Perfect.
And then you're gonna cross out the, you can put it out there, but
Yes.
pounds.
Pounds, inch,
But you're just gonna cross it out already.
correct. And I'm left with
300 something.
Kelvin. Well, think of it this way. I can take out, like
It's
this.
900, isn't it?
This would become 10, right? So 10 times 9 should be just 900. And isn't that what you just said?
Yeah.
There you go. 900 Kelvin, no, you do not have to switch it back.
How can you even do that math?
Because 300 divided by 30 is 10.
Wait. Inch squared?
The inches squared, pounds, inches squared cancel because they're top and bottom. And we're just left with Kelvin.
Okay, so what'd you do?
So I took 300 divided by 30, that's gonna give me 10. Because I can cross out this is 30 divided by 3, 30 divided by 3 is 10. 10 times 90 is 900. So it has to be higher than 900 degrees. And if I want to find out what Celsius is, I just subtract 273. Does it say what to do the temperature in Celsius? No. So we can do whatever we want with that. We'll leave it in Kelvin. You guys okay with me leaving it in Kelvin?
Yeah.
Alright, go ahead and try number 2.
Okay.
Is it the same formula except you,
Same formula.
well, it's to temperature. So you're gonna switch the temperature out for the pressure.
Alright, so you're looking for pressure, you're looking for the pressure here, which means when you solve for it,
It'll be P1 T2 over T1, right?
you're looking for P2, yeah. So it's gonna be P1, T2 over T1. And that's gonna be your P2, yes. That's your formula. Remember, always rearrange your formula before you plug in your numbers. Any idea why I asked you to do that?
Do you remember?
Well, yes, remember the formula. And also, when you put numbers in there, you start blending numbers together, you're going to start losing information because you're not sure what came from where, and if you make a mistake, it makes it very difficult to track. And, when it's just like this, you put your number straight in, you plug it, and you've got your answer.
What is that, 27?
So all you have to do is convert your temperatures, and then you're set to go.
For number two, with the equation, to plug the numbers in means P2 equals T1, P1 over T2 for number two. The final equation,
So we set this one, right?
like final formula, is put the numbers in.
Okay, so P1 is gonna be 900,
Yeah. P1 is 27, plus 270 over straight.
Isn't it just the same thing?
No, because this one was off of P2, this one's P2, but I don't know.
here, P2 equals P1 times T2 divided by
So
T1.
that's the formula?
Yes, sir.
Oh. right.
Because if you look at here, here's my original, I need to get this by itself, so I just multiply both sides by T2.
Yeah, that's what I did.
Alright.
Did you multiply it by the negative 1 and 2, right?
Yeah, okay, and then P2 equals.
Yeah, you multiply it by the 2, divide by the 1.
So. P1 T2 T1.
You did, yeah.
Miss Sweet,
Yes.
who's doing my lunch today?
Oh, me and Jacob.
Yes, Jacob and Gavin. You guys need to leave at 11:20.
Let's go.
And that's an hour and 20 minutes.
I will put that in our chat.
It's an hour, it's 20 minutes. I don't see them, why does it change when you try to look for something else?
What? Right here.
Right, that's the right answer. after this, what you do? You went down here,
Yeah, and this is the equation I ended up with.
P two equals
P one,
P, this is P two,
no, it's P one,
P one, and T,
T one,
T two, you said T two.
yeah, T two.
So that's not the
And now you can take the numbers from over here and plug in another equation.
Oh, okay, so then we, you said
900
900
times 9.
over 300, and that's it, like, and so it'll be 3, right?
And you just multiply these and then divide by that.
Multiply these two,
No, multiply these two and divide by that.
oh, what miss with, oh, okay. Would be,
The answer is 277.
Yep, 270 is correct.
no, I mean, it would be 81 or something,
No, yeah, this is not, this is,
100,
278,
No,
don't forget the
81,000.
millimeters of mercury.
I didn't, I put the K for Kelvin.
It's not Kelvin,
Is
though.
it-
It's pressure. You're solving for pressure,
Oh, okay.
which is gonna be millimeters of mercury.
Oh,
So
so
that-
NMHG.
Yes, sir. Because these are all Kelvins. And the Kelvin top and bottom cancel.
you know what I would do? I would, why don't you just divide this, make it 3, and then 3 times 90 is 270?
Are you getting this, Sam?
So,
That was smart,
And then over,
Thank you.
300.
Yes, yeah, over 300.
So you got
That's exactly
P,
it.
and then you'll.
2,
And then when you simplify it,
equals
it's gonna come out to be 270.
20, 270.
Yeah, that's what it
M,
is.
N, H, G.
And then your P2.
Wait, you have to do this, like, you have to do the other one up there.
Yeah.
Okay. I kinda get it.
Is
Avogadros,
is that easy?
um, fairly easy, but I'm not going to address it today. The
Oh.
reason why, you can cross it out. The reason why is because Avogadro's number is something we'll deal with when we're dealing with molecules.
Like this?
Yeah, like that.
Wait, so we're not doing Avogadro's?
Nope.
We're not doing Avogadro's law. Basically, what Avogadro's law says that 1 mole of a gas, and a mole is a collection of atoms, so it's, you guys know how much a dozen roses are, right? We're not doing it. You guys know how much it is in a dozen, right? 12 is in a dozen. How much is in a couple? 2. How much is in a few? 3. Okay, so with Avogadro's number, it's a specific number of atoms or molecules that are in that collection. Because atoms and molecules are so small, we can't see them. So in order to be able to actually weigh them, we have to have a whole bunch of them together.
Wonder if you can go to the.
And so what they did with gas is they said 1 mole, which is that collection, takes up 22.4 liters at standard temperature and pressure. Standard temperature is 0 degrees Celsius or 273 Kelvin, and pressure is 1 atmosphere. But we're not to that part yet. So we're gonna skip this portion of the calculations. Does it make sense? Okay, because we're just dealing strictly with pressure, temperature, and volume. That's the only thing we're dealing with. We're not gonna deal with moles yet. Moles will come later. Alright, good with this so far? Alright, jump to combined gas law.
Oh, man. Here's what it is.
Technically, I am a woman.
No.
You said woman.
No.
Bad joke. Alright, ideal combined gas law. Not ideal law. Combined gas law. So everything comes together. P1, V1. Sorry, P1, V1, T1 equals P2, V2 over P2.
P1 over. Oh wait.
Which slide do you guys need to have memorized?
What?
Which one of these 4 laws you need to have memorized? Correct. Why?
Does it follow them?
Yes, exactly. Alright. Look at the first one. Yeah, go ahead, you can read it.
Oh, the class?
Yes, sir.
Oh, a gas balloon has a volume of 106.0 liters when the temperature is 45.0 Celsius and the pressure is 740.0 mm of mercury.
Millimeters of mercury.
What will its volume be at 20.0 Celsius and 780.0 millimeters of mercury pressure?
Alright, so first thing we're gonna do is start labeling these. What is 1.06 liters?
V1.
Yep, V1. What is 45.0 degrees C?
T.
Very good. So you do 3 to it. What is 740.0 millimeters of mercury?
E1.
Correct. Have those all labeled?
Hey.
In fact, you can write them right above it in
You
your.
say, why do
on
you
your-
always use 273?
That's how we convert from Celsius to Kelvin. Everything has to be in Kelvin, because otherwise we could possibly divide by a 0 or a negative, and that's gonna mess us up. So we have to use the absolute scale to keep things straight. Alright, what is 20.0 degrees
T2.
Celsius? Yep, T2. And
T2. Oh, yeah. No. Oh, yeah.
20.0?
Yeah, you're right, sorry.
Nope, it's all good. I'll make sure we're on the same page. You're probably thinking of the 780 millimeters of mercury, which is our P2. We are looking for V2.
Oh my gosh.
Alright, so to get V2 by itself, I need to divide by P2 and multiply by T2. Does that make sense? Anybody too fast by saying that? Alright, let's do it. So P1 V1 over T1 equals P2 V2 over T2. This is the guy I want. So I'm gonna multiply by T2, get cancel, divide by P2, get that cancel. So T2, P2. So V2 equals T2, P1, V1 over P2, T1. Two, 3 Kelvin. This is 3.
I'm stuck at the formula, dude.
You're stuck at the formula?
I'm stuck at where like you started writing.
Okay. You understand that this is the original.
Okay.
I need to get V2 by itself. To do that, I have to divide by P2 because it's being multiplied. Divide by V2, divide by P2. I have to multiply by T2 to get it off the bottom. Multiply by 2T, multiply by T2. T2 cancels, P2 is canceled, I'm left with just V2. So V2. Then I just write T2, P1, V1 on top,
Oh,
P2, T2 on bottom.
oh,
Okay.
that makes sense.
Is this 218, Kevin?
I got 328.
328.
Ooh.
You might be right though.
I did it in my head.
Yeah, you did, yeah, you're right, I'm wrong,
You sure?
yeah. You got 30 onto that, that's 303 just plus, 15, that's 318.
Okay. Thank you. So I know my little brain does all sorts of fun things when it's, yeah. Dyslexic brains do weird things. T2. So I've got 293. P1 is 740 millimeters of mercury. Don't forget the units, Mrs. Beadon. Alright, and then I have V1, which is 106.0 liters. Okay, good so far. Did I get them right?
You see, I'm gonna run out of space. That's what I put.
I understand. Alright, T2, that's correct. P1, that's correct. V, okay, that's correct. Now I divide by P2, which is 780. Wow, 780.
You can't write anymore.
Yeah, I'm sorry, this takes such space. And then my T2 is,
399.
you mean 318.
Yes, very
Yeah.
clean.
Alright, the
Oh,
reason
wait.
why I wrote it this way is so that I can cross the kelvins out, millimeters of mercury, I'm just left with liters. So I did do that correctly, that's my dimensional analysis. And I multiply straight across, top and bottom, so we get
You say 980? No.
293 times 740
So long.
times, no, 6 I know, right?
Oh,
Whoa, that's a big
can't even
number.
write the formula anymore.
22982920.
Yep.
What? Paul,
That's what happens when I multiply 293 times 740 times 106.
And then the bottom one is 248040.
You guys done yet?
Well, I didn't put them all in at once. Okay,
they make all of
so then I just go 2, 2,
Yeah, look, you understand.
3, 2, 9, 2, 0,
2, 4.
and I divide by 2, 4, 8, 0, 4, 0.
92.
92.65.
5811996.
Is that gonna be your answer, Sue?
Alright, that's liters, right? How many significant digits do we have? We have, how many here?
3,
3, we have
4.
4,
4,
4,
4,
3,
3, 4, so we're going to only go with
4.
2.
the lowest number.
Three.
Oh, and 3.
3. So we have to round to this number. So is that 4, sorry, thank you. So does that round up or stay the same as what I was trying to ask? But yes, it becomes a 7. So it's gonna be 92.7 liters.
So I don't have space to write the answer down.
You can go up the side.
Yeah, I can't do that.
There's space right here.
Which means I can't write this. Wait, yeah, you say?
92.7, that was
It
there.
doesn't make sense, 'cause look, you see where they have to round the number?
Yeah, I see that.
It's like all the way on the other side of the paper, and then the answer's gonna be like on the other side.
Where did you put your hand?
Like, see, that's like where the rounding's at?
Okay.
Round that.
So just write it right above, do a little arrow above, write the answer in, and then box it. Alright, everyone have a rough idea how this works? Alright, these are probably the ones that are going to take the most space, simply because we have so many variables that we're working with. Okay?
I'm just waiting for the second one. There's no T2, P2, or V2.
Give me just a minute. They do have T2 and P1, T1 and P1 are there. They are, so standard temperature and pressure, you need to know what that is. So STP is standard temperature and pressure. Abbreviate is temp and pressure. Okay, temperature, in that case, T is gonna be 0 degrees Celsius. And P is, did they do it in atmospheres? What did they do it in? Millimeters of mercury?
Yeah.
Alright, so with millimeters of mercury, it's gonna be 760 millimeters of mercury for standard temperature. Sorry, standard pressure.
Is that T2?
That's by definition. So by definition, STP is standard temperature and pressure. Standard temperature is 0 degrees Celsius, standard pressure is 1 atmosphere, or 760 millimeters of mercury, which is what we're working with today. Make sense? It's also 76 torr, it's also 101.3 kilopascals, let's go on. Alright, so this is gonna be T1, this is gonna be P1 for number 2. And you have V1. V1 is
10 liters.
no, it's gonna be a gas and volume of 4.0 liters. That is your, wait, I'm looking at the wrong problem. It's 10 liters. Alright, does that make sense? So we have T1, T1, V1. Okay, it's heated to, so we have T2. T2 is 560. That's, wow, where'd that come from? 512 C. They want to know what V2 is.
Alright, hold on.
And then the new pressure is 1520.0 millimeters of mercury. Alright.
How'd you get 760?
So by definition, standard temperature and pressure is 0 degrees Celsius, 1 atmosphere. 1 atmosphere is 760 millimeters of mercury. It's on the, if you look at the front here, see it says ATM. ATM equals how many millimeters of mercury? 760. So that's where it's coming from. That's the definition. May I erase this one here?
We're looking for V2?
We're looking for V2 again. Yeah, just like before. So we're gonna use the same formula, which I just erased. We're gonna be using this formula.
So just put it down?
Yeah. Well, we already solved it first, so no point in redoing the work we've done already.
V2. V2 equals
So you just plug your numbers in, and you can solve.
Did that same?
It's the exact same formula this time, just very convenient.
How'd you get 885?
That's 512 plus 270.
said?
What do you say? What do you say?
We haven't said anything yet, we just put the numbers in.
Is the low, oh no, it's two.
Did I put it in wrong?
No, it's because I already have the answer, I'm trying to do the rounding thing.
Oh, okay, so we've got 3 here, 3 here, technically 1 there. Well, this could be 3.
Okay.
So 3, 3, 3, and 3, so just give me 3.
So that means.
So it would be number 2, right? It would be 2, because that's what we did last time.
Yeah, so then it'd just be 16.21.
I think it's this. Or was it just two? I guess it's just 16.
No, it's 16.6, yeah, last time it was 92.6, 92.7.
Oh, so we got different numbers than me, like way different.
Me?
Yeah, your first number?
Okay, let me try again. 785.
785, I got 885.
Oh, did I do it wrong? That's
673 plus 512. 200 plus 500 is 800. 73 plus 12 is 80.
You're right. No.
Oh, no,
This
she's
is
right.
right. This is right. I just blinked in.
Oh, she is right. Shoot.
Oh my gosh, now I have to restart the whole entire thing.
No, you just fix it.
Exactly, sorry.
No, if you start over, that means you have to start from labeling them. You don't do any of that. You just have to fix this one here, and then fix that, and then your results.
But so what do I fix? What do I erase?
This one here. That's the one you need to fix.
You need to do a new number. Oh wait, yeah, because we already have the number up there.
Yeah. So this is gonna be
I should get 85.
14.3772. Yeah, it's in liters. It's liters again. So this is 14.4,
0.4.
yeah. Right, and that's class.
Okay, so we're gonna finish the last one tomorrow. Last 2 tomorrow.
Wait,
They're
what?
your homework.
What number do you,
And we got study hall.
what number you find out?
Oh, I have to come up with your list.
Oh,
Yes.
final number is 14.3723.
For V2?
Yeah, 14.
Oh, P2?
Yeah.
23.
So,
Seven,
P2
seven.
here,
Yeah.
so it's gonna
2,
be,
Oh.
And then round it, right?
yeah,
T2.
14.4.
P1, V1, all over
Oh, sorry.
So you got this tomorrow?
V2, T1. Uh-huh.
I still need to do,
Oh, wait, that's the formula for which one?
I think it's for the next one. You just rearrange it.
Oh, rearrange it.
Do I need to go over how to rearrange things?
I'm like,
Because we can do a whole lesson on that. I have no problem with that. Okay, just double check.
so we'd be looking for P2.